Welcome back, everyone. Let's move straight into some Rhema questions. We sincerely do not know how far we can go on this, but let's hope that the little we can cover will go a long way in our exams. Okay, here we are looking at some Rhema questions on Chem 101, and let's start with question number 1. Question 1 talks about isotopy. Question 1 says chlorine contains two isotopes with mass numbers 35 and 37. If the relative atomic mass of chlorine is 35.5, calculate the percentage of chlorine 35. Now, let's use here this side of the board to work our calculations. Now, relative atomic mass of chlorine equals to 35.5. And we are meant to understand that chlorine has atomic number 2 isotope with one mass number 35 and mass number 37. Now, here is where chemistry comes in. Now, when you look here, you will discover that the difference between mass number 35 and mass number 37 is 2. Write it out. Now, when you look careful, you look at the relative atomic mass is 35.5. Now, if the difference is 2, 35.5 minus 35 is 0.5, which means the difference here is 0.5. That is for 35. Why 37? 37 minus 35.5, 37 is equals to 1.5. What does that tell you? That tells you that 35.5 is closer to 35 is closer to 35.5 than 37. That tells you that chlorine 35 is in the ratio of 1.5 ratio 0.5. It's a ratio of 3.1 to 37.5. Now, if the ratio of chlorine 35 is actually 3:1, because we know that 35 is closer to 35.5 than 37, which means chlorine 35 is a ratio of 3:1. So that means chlorine 35 actually has, out of 2, 3:1 of 2 is 1.5. Where 3:1 of 1:3 of 2 is 0.5. That means chlorine 35 has 1.5. Since we are talking about percentage, it's going to be 1.5 times 100. And when you calculate 1.5 times 100, it's going to give you 150. Now, since the overall of them is 2, the relative atomic mass of both 37 and 35 is 2, you divide by 2, which means chlorine 35 is going to give you a percentage of 75%. 75%. Okay, now, since we already know that chlorine 35 has a ratio of 75% now, and we know that the overall percentage is 100, how about we are asked to calculate the ratio of chlorine 37? Automatically means that the ratio of chlorine 37 is equals to 100 minus 75, which is equals to 25. And if you cross-check it, it will give you, it will also give you 3:1, which means our answers are correct. Now, let's twist the question the other way around. Okay, here we are given the two isotopes and we are given their relative atomic mass. Okay, let's say for example we are not given the relative atomic mass. We are given the ratio of chlorine 35 to 37 and we are asked to calculate their relative atomic mass. Or let's say for example we are given their percentage and we are asked to calculate their relative atomic mass. Okay, first of all, let's work with the ratio and we'll work with the percentage, because these are the three ways that they can set questions for you when it comes to isotopy. Okay, let's say 35, 37. What if we are told that the ratio of chlorine 35 is 3 and the ratio of chlorine 37 is 1, and we are asked to calculate the relative atomic mass of chlorine. Okay, now since chlorine 35 is 3 and chlorine 37 is 1, in calculating their relative atomic mass, know one thing, which means that the combined ratio is 4. So when calculating for 35, you say 35 times 3 plus 37 times 1, which is equals to 37. Now we'll calculate 35 times 3 times 2 is 70, plus another 35. We're having 105 plus 37. And when you calculate 105 plus 37, approximately 105 times 37, you are going to get plus 37 will give us 142. Now when you divide 142 divide by 4, what is it going to give you? 142 divided by 4 is going to give you 35.5, which is to 35.5, which is to tell you that the relative atomic mass of chlorine is 35.5. Now let's try it the other way around. Let's say, for example, you are given the percentage and you are told that chlorine 35 is in 75% and chlorine 37 is in 25%. Now, which means that the combined percentage is 100. So what you do is 35 times 75 plus 37 times 25, everything divided by 100. You are still going to end up getting 35.5. So in other ways, in any way that they give you, you should be able to solve any question relating to isotopy. Let's say we are done with isotopy. Let's see how many topics we can cover in this Rhema. Okay, question number 2 says, reaction rate in nuclear reaction is affected by. Now, in your past question, if you see question like this, it was actually given like this in your past question. They said the reaction rate in nuclear reaction is affected by the put-in pressure, the put-in temperature, the put-in concentration, and I think the put-in is it the number of nucleus or the amount of nucleus? Now, when we talk about nuclear reaction, what is nuclear reaction? Nuclear reaction is a reaction that occurs spontaneously. Spontaneous. Now, let's go straight to nuclear reaction. Nuclear. Let me rewrite. Nuclear reaction. Don't forget this Chem 101 with exquisite tutorials. Now, nuclear reaction is a reaction that occurs spontaneously. One thing that you should know that about nuclear reaction is spontaneous. Now, and when we talk about something being spontaneous, it means something that occurs on its own. It occurs naturally without any other effect. Now, the difference between nuclear reaction and chemical reaction is that nuclear reaction occurs on its own. But when it comes to chemical reaction, you have to mix two chemicals together, or elements will come together to form a reaction. But once you are talking about nuclear reaction, it's spontaneous. Now, one thing you should know about nuclear reaction being spontaneous is that since it's spontaneous, it's not affected by pressure, it's not affected by temperature, it's not affected by concentration. All those things do not affect nuclear reaction due to the fact that it occurs on its own. And when we talk about nuclear, that means we are talking about nucleus. Nucleus. And don't forget, what makes up the mass of an atom is what makes up the mass of an atom is the proton number plus neutron number, and these two occurs in the nucleus of an atom. So that is to say that the nucleus of an atom determines its mass. So that is to say that, I don't know if you understand, this is an atom, the electron are this, while the proton and the neutron are here. Proton, neutron. Now, here is where the mass of an atom is located. Now, we are talking about nuclear reaction. It's a reaction that occurs in the nucleus of an atom. So, the nuclear reaction has to do with the nucleus. So, when you are seeing any other option, once you see an option that is related to the nucleus, number of nucleus are affected by nucleus, and you are talking about nuclear reaction, click the one that is talking about nucleus, because it happens on its own, it's spontaneous, and talking about nuclear, it happens with the nuclear reaction. Now, there is two terms that you have in a nuclear reaction sharply. Two terms that you must note in a nuclear reaction. One, we have nuclear fission. Another, we have nuclear fusion. Now, note, one is fission and one is fusion. Now, when we're talking about fission, fusion has to do with big mass of a substance disintegrate to form smaller mass. Okay, let's say, for example, we have decane as number 10 in the number 10 in your organic naming, in your nomenclature. When a substance that has a mass number of 10, let's say when the decane disintegrates to form ethane and octane, is a nuclear fission, whereby a big substance is being breaking down. Okay, let's say, for example, if this is breaking down to form this small marker, and this small marker is a nuclear fission. But when we talk about fusion, fission means this small substance plus small substance into a bigger substance spontaneously. Remember, when we talked about nuclear reaction, we started with being spontaneous. So that means this is a nuclear fusion. Now, one more thing you need to know about nuclear reaction. When we are talking about nuclear reaction, we talked about the alpha particle, the beta, and the gamma. Now, we made us to understand that the alpha particle has the charge of helium, which is a mass number of 4, and a neutron number of 2. A neutron number of 2, helium. So whenever you see a substance disintegrate, or let's say, for example, a substance that has, let's say, N is a substance with mass number 36 and proton number of 10. Please, this is just an illustration. Once to produce N with, to produce, let's say, for example, W with to produce W with a mass number of 32 and a proton number of 8. What happens to here is an alpha emission. It means an alpha particle was given out. So once you see, this is 10, don't forget. Once you see a nuclear reaction like this, just know that an alpha particle has been given out. For example, how about when you see a nuclear reaction like this, N having a mass number of 36 and a proton number of 10 to form W with a mass number of 36 and a proton number of 11. This is a beta disintegration. It means that now a beta particle has to do with E minus, which is addition of one addition of one electron, you know, E minus, when you're talking about ionization, once you have E in an ion, it means a particle was added, or an element or an electron was added to the atom in its neutral state. I think that should be all for nuclear reaction. Now let's take another question. Question number 3. I hope we are following. It's all about Rhema. We'll have to be fast about that. An element with atomic number 22 will fill which orbiter? An element with atomic number 22 will fill which orbiter? So this particular question number 3 is talking about electronic configuration. So we have moved to another topic talking about electronic configuration. Now, I want to show you how the electronic configuration has to do with the energy levels. And we started with 1s, 2s. Okay, probably we should complete it for you to understand. 1s, 2. S can only contain 2 elements. S can only contain 2 elements. 1s2, 2s2, 2p, 6, 3s, 3p, 4s, 4s, 3d, and the rest. Okay, now, when we are talking about, let me explain this first. An element with atomic number 22, you know, from in your periodic table for 21 to 30 are what we call the transition metals. And the transition metals fill in the orbiter of D. So whenever you're talking about the transition metal, just know that it's D. So once you see 22, don't just look elsewhere, just check D and that is the answer. We're talking about your transition metals. Now let's talk about the electronic configuration. Okay, let's say for example, they say or let's say an element with atomic number 11, element with atomic number 11, what is the electronic configuration? Remember is 11. So we have 1s2, 2s2, 2p6, we already have 2, 2, 10, 3x1. So this is the atomic configuration of sodium. How about, okay, this is just how you arrange your atomic, electronic configuration of elements. You just follow it. It's like this: 1s, 2s, 2p, 3s, 3p, 4s, 3d. Now the reason why 4s is coming before 3d is because 4s has a lower energy than 3d. Then after 3d you have 4p, continuously like that. So that is how you do your electronic configuration. Okay, let's take another question. We are done with electronic configuration. Okay, the number of electrons in chlorine ion is dash. Now this one is talking about I think here, okay, let's take this question to your periodic table and the rest. Okay, now let's talk about the ions. Now we have ions, and we have negative and let's say positive ions. Now these are ions of non-metals. These are ions of metals. Now let me explain. Ions of non-metals. You know that non-metals accept electrons to gain their electronic configuration into an octet or a stable configuration, while metals give out electron to gain a stable electronic configuration. So whenever you see a metal with this sign, it means the metal has given out an electron. And when you see a metal with this sign, it means the metal has gained an electron. Now, let's say, for example, here's it's saying the number of electrons. Now, normally, the number of electrons is the same thing as the number of proton in a natural element. Okay, let's say, for example, this is chlorine. This is chlorine. The number of electrons of chlorine is number 17. Chlorine is number 17. So the number of electrons of chlorine is supposed to be 17, which is same thing as the number of protons. But when chlorine has a minus, it means chlorine has accepted an electron. So 1 electron. So which means 17 plus 1 is equals to 18. This is what this minus means. Now, when, let's say, for example, sodium with a proton number of 11 loses an electron to form sodium ion, it means sodium has lost an electron, which is equals to 11 minus 1 equals to 10. So whenever you see elements like this in the ionic form, when it's a non-metal with minus, it means it has accepted an electron, or a non-metal with plus, it means it has gained an electron. Okay, let's say, for example, a metals like magnesium. Okay, here is Mg, 2 plus, and here is oxygen, 2 minus. This means that oxygen, which is oxygen, which is number 8, has a proton number of 8, has accepted 2 electrons to form 10. While magnesium, which has a proton number or a natural electron number of 12, when it's plus 2, it has lost 2 electrons to form 10 as well. So that's what you need to know about your metals and non-metals. Okay, from here, I think we should talk about something else regarding elements. What can we talk about on elements? Okay, let's give you some hints. Now, in an element, just like I told you, the mass of an element is determined by the number of protons and the number of neutrons. Also, the position of an element in the periodic table is determined by the proton number, which also determines the reactivity, which also determines the reactivity of the element. Now, did you guys talk about reactivity? Just know that when it comes to the periodic table, elements in group 1 are more reactive from the down, while elements in group 7, which are the halogens for non-metals, are more reactive than the up, that is the reason why the first non-metal, which is fluorine, that is the first halogen, is the most reactive non-metal, while the least cesium is the most reactive metals. What else should we talk about? We have talked about an atom, element, proton, and the rest. Okay, now let's talk about how many moles and atoms of carbon atom are there in 0.5 moles of C2H6. Now this one is talking about stoichiometry. Now here, C6H2 means that now when you are calculating moles and numbers of atoms, once there is no number here, it means the mole or the volume of that compound or element is 1. But when you are seeing 2 here, it means that the mole or the volume is 2. But when you are seeing numbers attached to the elements, each personally, it means they are talking about the numbers of atoms of that element in that compound. Now, first of all, they say we should calculate moles. Now, let's see here. According to what we have here, 1 mole of C2H6 ethane contains how many carbon do we have here? That is the mole of carbon. Just like, look here, there's no number here, so we have contains 1 mole of carbon and 1 mole of hydrogen. But when you look here, you have 2 attached to carbon and 2 C's attached to hydrogen, which means the same. Now, here in general represents the compound. This one represents the elements. This one represents the elements. Here, there's no number attached here, so it's the same thing as 1 mole. Here, there's no number attached here, 1 mole. Here, there's no number attached here, 1 mole. But generally, there's no number attached to the compound like this. So it means that this compound is 1 atom of ethane. But here, there is 2 attached to carbon and there is 6 attached to hydrogen, which is to tell you that a compound of ethane contains 2 atoms of carbon and 6 atoms of hydrogen, but the same, and 1 mole of carbon and 1 mole of hydrogen. So first of all, they said we should calculate for the number of moles. Now, calculating for the number of moles. Now, the number of moles is 6.02. 1 mole is equals to 6.02 times 10 raised to power 23. Okay, now 1 mole of this element contains 2 atoms of carbon, which means 0.5 mole of this element will contain 1 carbon of atom. And mind you, 1 mole of a substance is equal to 6.02, which is the same thing as 1 times 6.02 times 10 raised to power 23 is equals to 6.02 times 10 raised to power 23. Now, let's do the last question on stoichiometry. This one said, how many mole of copper are in 162 gram of copper? Now, 1 mole of copper, 1 mole of copper contains 63.5 gram. Now, if 1 equals to 63.5 gram, that means 162 gram, 162 gram of copper will be equals to 162 times 1 divided by 63. And 162 divided by 63 is same thing as 2.55. 2.55 mole. Now, how about when we are given the number of mole to calculate the number of atoms? What if we are given how many atoms, of copper are in 2.55 mole? Since we know that 1 mole is equals to 63, therefore 2.55 mole is equals to 2.55 times 63 equals to 162. So 1 is equals about mole and mass. They are almost related and same thing. Stay tuned. Let's see if we can take more Rhema questions to explain different topics in your Chem 111. Or sorry, Chem 101. It's exquisite tutorial. You know we love you.